Alrighty, here we go. We are on the exercises for homework 2.4 on biconditionals. This is page 99. Hey, we're about to break 100. Numbers 1 through 19, 27, 33, 39, and 41 odd. Okay, and I'm going to be working through problems 3, 5, 9, and 27. So let's take a look at number 3. Number 3, the instructions. Always read the instructions. It says write the conditional statement and converse within each biconditional. So they're giving us a biconditional, and we've got to find the if-thens within it. So number 3 reads, your medicine will be ready by 5 p.m. if and only if you drop your prescription off by 8 a.m. All right, so I'm just going to look at those two clauses and say your medicine will be ready. And we'll go ahead and say if, let me change my color here, if your medicine, I'm going to do some abbreviations not to drag this out. You can write it out more neatly. If your med is ready by 5 p.m., then you dropped it off by 8 a.m. So if you drop it off early enough, you can be ready the same day at a certain time. So if your medicine is ready at 5 p.m., then you dropped off the prescription by 8 a.m. Alrighty, so then the converse of that would simply be to switch it. So we're just going to take the drop off and the readiness and swap those two. So if you drop off your prescription, well, let me just write it the same way I wrote it above. If you drop, you can write it out again more fully. If you drop it, if you drop it off by 8 a.m., then your medicine will be ready by 5 p.m. Okay, and so we've taken that biconditional, we've removed the if and only if, taken each clause and said and wrote them as if-then conditional and converse statements. Now it doesn't ask, there's no way to evaluate this or anything else. So we're just practicing splitting them. Okay, so let's look at number 5, where I think we're going to reverse this process. Okay, number 5 is instructions say for each conditional, write the converse and a biconditional. So yeah, we're going to start with an if-then, write a converse, and then form a biconditional. So number 5 says, if two segments have the same length, then they are congruent. Let me go ahead and write that out just so we can see it. If two segments have same length, then they are congruent. Notice I even separate the two clauses by lines. It kind of helps me keep them differentiated. So now for the converse, I just need to switch those two things. And so I'm going to take the congruent part and put this idea with the same length here. So if two segments are congruent, then they have the same length. Okay, so we just simply switched our hypothesis and our conclusion. And so that's the first part. The last part is it says write a biconditional. So that means we're going to use our keywords if and only if. So two segments are equal in length. And here comes the keywords, if and only if they are congruent. And you can see that's a pretty good definition of congruent segments. They have the same length, which is why this is not only a biconditional, it's a true biconditional, and thus a good definition. And again, just so you know, I could have put the conclusion and the hypothesis in either order. I could have also said two segments are congruent if and only if they're equal in length. So either one would have been fine. The main idea is that you take the two clauses, the hypothesis and the conclusion, and you link them together with the if and only if. It doesn't say to evaluate it, but this is a true statement. Okay, let's take a look at number 9. You want to be able to transition between a definition, a biconditional statement, a converse, and a conditional statement. All right, number 9. Let's look at that one. Now it says write each definition as a biconditional. So now they're giving you a definition, and we have to turn it into an if and only if statement. So number 9 says, a hummingbird is a tiny, brightly colored bird with narrow wings, a slender bill, and a long tongue. All right, so this one's a little confusing just because there's so many descriptions, and you might think, oh my gosh, I got to somehow have equal halves. I need to take half of it over here and then say if and only if over here. Don't necessarily think of it that way. The idea is, what are the two ideas? One is a hummingbird is a bird is a hummingbird if and only if then you have all these characteristics. So your main, I'll just kind of sketch it. Your main ideas is you have hummingbird, and then you have this big long list of characteristics, which I will write out, but it'll take me a little while. And so we can start our if and only if statement, and we can say a bird, well, I will say, actually, let's even just do it this way. It is a hummingbird if and only if it is, and then all the rest is that clause. If it is a bird, or we should say, whoops, a brightly colored bird with, and all the rest, narrow wings. So you can have a really long hypothesis. Slender bill. Didn't know you're writing essays in geometry, did you? And a long tongue. Okay, and so there we have our two clauses, hummingbird. Here's our key phrase, if and only if, and then the rest of this is all the other P clause. Okay, and the key idea is in that definition, just look for the word is, and where the word is, the linking verb is in the definition, that's where you're going to pretty much always put your if and your only if. Alrighty. So we took a definition and we turned it into a biconditional. If I wanted to, I could write a conditional. If it is a hummingbird, then it is a brightly colored bird, blah, blah, blah. Or I could say, if it is a brightly colored bird, blah, 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 then it is a hummingbird. So we could do that too, but this problem's not asking us to do that. So let's move on to the last one I'm going to work with you through, because most of the other ones through 19 are very similar to these. Let's look at 27, where we have to evaluate a definition based on our knowledge of biconditionals. Oh, that looks terrible. 27. All right, 27 reads, we have to explain why the statement is not a definition. And the definition they've written here is, an automobile is a vehicle that moves along the ground. Okay, so an automobile is a vehicle that moves along the ground. Well, and so when they say to ask why it's not a good definition, we need to look at it as a biconditional and why that's false. Well, let's look at our two statements here. An automobile is, there's the linking verb, a vehicle that moves along the ground. If we write that as a conditional statement, we would say, if it is an automobile, then it is a vehicle that moves along the ground. That's pretty good. Okay, I'll take the conditional. It's not talking about hover cars and getting all crazy. But if I reverse it and find the converse and I say, if it is a vehicle that moves along the ground, then it is an automobile, then you're in trouble because there are counterexamples. So the converse, or I'm sorry, the conditional of auto moves on ground, kind of a thing, that's okay. Check. But the converse of that, where moves on the ground has to be a automobile, that's no good. Okay, because what? You've got a bike, you've got trains, you've got wagons, you've got vehicles that move along the ground, carriages, skateboards. So that's not a good definition of an automobile. So you can see why looking at things as conditionals and biconditionals allows you to see whether or not a definition is adequate or not. And the way I would summarize this is I would just say can't be written as a true biconditional. Okay. It is anyway, so that's how you would want to evaluate your definitions. All righty, good luck on 2.4 and reach out if you have any questions. Good luck.